Hello, welcome to lesson number 2 in the 5th spiral. So today we're looking at volume of spheres. So I want you to be able to demonstrate understanding of how to determine the volume of a sphere. So a formula for a sphere, in earlier lessons we came up with or developed the formulas based on some of the other shapes. In the case of the sphere, I'm not going to bother. The formula is complicated in order to develop from first principles. So it's going to be on your formula sheet. So if you draw a circle and you put those dashed lines in there, kind of makes it look like a sphere. So center of the sphere to the outer edge is what we call our radius. All right, so if we want to find the volume of a sphere, the formula is volume equals either 4/3 pi r cubed, or the formula you're probably going to be more comfortable with in terms of calculating is 4 pi r cubed over 3. All right. The only thing I need to review here is that r cubed. All right. The r cubed value. So in order to find r cubed, I'll just do it down below as a reminder. So reminder, r cubed means r times r times r. Okay? It's like a pirate. That's a joke. It's funny. R times r times r is r cubed. Now, if you want to calculate this with your calculator, you are looking for the following buttons. It could look like this. All right, we'll call the carrot top or the hat. Or some calculators will have an x to the y, or some will have a y to the x. So if you have your calculator handy, okay, and you want to punch that in, so for example, 3 cubed is 3 times 3 times 3, so that is 27. So if you can use that on your calculator, you would have punched in 3, let's say it's the XY button, 3, and hit equals. That gives you 27, or if we do another one, just to practice with your calculator, 2.5 cubed. So on your calculator, you would punch in 2.5, the XY button, cubed, equals, and in this case, 2.5 cubed gives me 15.63. So 15 point, it's actually 625. All right. So if you're trying that with the calculator, okay, that's the button you're looking for. So you can double check to make sure you have that. If you're using your iPad or your cell phone calculators, you have to turn the cell phone sideways because you need all your extra notations to find those buttons. All right, so there we go. So we're just going to practice using the sphere. So if we flip over the example, sphere has a radius of 12 centimeters. What's the volume? The key here is to make sure you actually have the right measurements. So we have radius, and that's exactly what we need. So volume equals 4 pi r cubed over 3. So that's 4 times 3.14 times 12 cubed divided by 3. And again, this is the important part. You want to be able to make sure you punch this. You can punch this into your calculator and get the correct answer. So if you want, just tell either hit pause on the video or get someone to pause it so that you can try this on your own. But you should be able to get 7,234.56 centimeters cubed. Okay, so you want to make sure you have or you can calculate it. Next, example 2. Got to be careful. What measurement are we actually given here? We are given the diameter. So a sphere has a diameter of 18 millimeters. Remember that our diameter would be the entire distance across the sphere from one side to the other. That is not the measurement. So right away, before I go to the formula, I'm going to write down a note for myself and say the radius is actually 9 millimeters. From there, it's just going into your formula. 4 pi r cubed divided by 3. So 4, and again, you want to try this with your calculator to make sure you can get this. 9 cubed over 3. So again, just as a note, you would punch in 9, x to the y button, 3, in order to get that. And you can do that all in one calculation on your calculators. So again, if you're trying this on your own, you should get an answer of 3,052.08 cubic millimeters. All right. And as I said, you want to make sure you can get this on your own. So make sure you do try this with the calculator, because this can be frustrating if you can't get the correct answer. All right. All right, on to the next example. So what happens to the volume of a sphere if the radius doubles, triples? What's the pattern? All right. So let's do just our normal formula. So our volume is 4 pi r cubed over 3. So that is, let's say that's our starting sphere. Okay. If it doubles, so it doubles. So this would mean, therefore, my r value, and we're going to leave it as r, would become 2r. Okay. So we're doubling the radius. So let's look at what happens to our formula. Volume equals 4 pi r cubed over 3. Well, everywhere there's an r, I'm now going to replace it with a 2r. So in brackets, 2r cubed over 3. So what happens with that? Well, we would cube everything inside. All right. So we would end up with 4 pi times 2 cubed times r cubed over 3. I'm going to pull out the normal stuff. And when I say normal stuff, I'm going to take this and keep it separate. So I'm going to put it inside brackets. So that would mean that in brackets, I would have the 4. Here's the 4. Here's my pi. Here's my r cubed. And here's my 3. What's left over? The only thing that's not in there is the 2 cubed. So 2 cubed, 2 times 2 is 4, times 2 is 8. All right. So if the radius doubled, therefore, what happened to the volume? The volume got 8 times bigger. So therefore, whoops, I'm going to do therefore one more time again. Therefore, the volume got 8 times bigger. All right, so we need to do one more, excuse me, one more shape in order to kind of make a comparison here or figure out what the pattern is. So the magic of technology, I'm going to group that all together. I'm going to shrink it down for a second. All right, I'm going to do deal with the tripling now. So if we're dealing with triple, so now my r, I'm going to do the exact same thing I did over there. R is now going to become 3r, so it got multiplied by 3r. Using my volume formula, 4 pi r cubed over 3. So I'm going to replace the r with 3r now. So 4 pi 3r cubed over 3. So now, again, everything inside gets cubed. So now we have, slide down a bit, 4 pi 3 cubed r cubed over 3. I'm going to do what I did last time. I'm going to pull out the 4 pi r cubed. All right, so the original formula, 4 pi r cubed over 3. So I'm taking out the original stuff, the 4, the pi, r cubed, and 3. What's left over is the 3 cubed, and 3 times 3 is 9, times 3 is 27. So therefore, the volume is 27 times larger. All right. And then again, I'm just going to shrink this so that I can bring it all together. So what is the pattern here? Because that's what the original question wants to know. What happens, or what is the pattern here? Well, hopefully you can see that the pattern is if I double the radius, the volume becomes 2 cubed bigger, or 8. So 2 cubed bigger. The volume here, the radius tripled, well, that became 3 cubed, or 27. So whatever you do to the radius, you put it to the exponent 3, all right, for volume. So whatever happens to the radius, that, oops, I'll put that value, is to the exponent 3. All right, so what would happen here? So just as an extra, all right, what happens if I, what happens if I made the radius 10 times bigger? So if I made the radius 10 times bigger, therefore the volume would be, and again, the pattern is just take that value. How many times bigger did I make the radius? It's going to be 10 cubed, or 1,000 times bigger. All right. So this is something you'd see in a multiple choice question on EQAO. I'm definitely putting a question like this on the test for this unit, all right, where it's just making that direct comparison. So you don't have to do all the work above. We just need to remember, all right, whatever happens to that radius, we cube that value to find the resulting change to volume. All right. If you have any questions at this point, this is the end of the lesson on spheres. If you have any questions or concerns, make sure you do ask, or if there's something you didn't understand, and we'll get that cleared up, and we'll see you in the next lesson.